the block of wood on the tabletop. Okay, and the mass of the block is, so let's say this is our table, and then there is a block of wood. So let's say it is somewhere here. Okay, so it's saying that the dimensions are, let's say this is 40 centimeter, and then 20 centimeter, and then 10 centimeter, and it's given that this is about 5 kg in mass. So it's asking calculate the pressure exerted by the block on the top if it is made to lie on the top with its sides of dimension 10, 20 and 10, 40 and 20. So let me so we have two questions here. One, when the block is laying on the ground with there's a different something here. So this one is let's say 20 centimeter and this is 10 centimeter. Let's do this problem first. Okay, so we know mass is given is about 5 kg. Okay, and we know thrust, pressure and thrust. So pressure, it's asking to calculate. We know pressure is going to be calculated from thrust, which is going to be weight of the object. So thrust is going to be mass into gravity, so which is going to be 5 into 9.8. This is going to be around 49 Newton. So that's the thrust. Now for calculating the pressure, you need an area. So area for the problem 1 is going to be the area which is touching, so which is touching the surface of the table and the wooden block. So that would be, and if you think about this, that would be all this area which is going to be touching the surface, right? So, and that area is telling us would be it's going to be rectangle. It's a rectangle area which is touching the surface, and it is, the dimensions would be of the 20 centimeters if I calculate the areas into 10 centimeter, right? So that would be about 200 centimeter square, and I would like to convert that into SI unit for our problem. So that would be about 0.02 meter square. So the pressure is nothing but thrust upon area. I can divide this 49 Newton divided by 0.02 a meter square. That would be 2450 Newton per meter square. That's a pressure which this block is exerting on the top. Okay, so now in the second bit, it is telling us that we just rotated the block. Now the sides touching, which would be 40 centimeter and 20 centimeter. So again, we know from our previous calculation, so this is part 2, right? Part 2. So from previous calculation, we know thrust is equal to 49 Newton, right? Now the thing which is changing is the area. So area which is touching the tabletop, this would be 40 centimeter into 20 centimeter. Okay, so this is going to be around 800 centimeter square. That would be 0.08 meter square. And the reason I'm converting it to meters because of SI units. I want everything to be consistent. So pressure, which is basically given by thrust upon area, is going to be 49 Newton divided by 0.08 meter square, and that would be about 612.5 Newton per meter square. Okay, so just look at it, like just by slightly rotating the block, the pressure has decreased quite a bit. It was 2450 Newton per meter square. Now it is 612.5 meter per second square. I hope that gives you a good understanding of the thrust and the pressure. So thrust is the force which is acting on the object perpendicular to the surface, and the pressure is basically thrust upon area. Okay.